Hello all and welcome to the last lesson of your first unit. If you're doing this a little bit early, you're going to get an email on Wednesday talking about the test. If you're doing this in order, you've already gotten that email to your parents' account as well as to your own, so please review that and let me know if you have any questions about how the test is going to work. But let's start by taking some notes on this last topic. You'll notice that there is a worksheet for this instead of problems coming from the textbook. That worksheet is attached to the assignment that you're watching this video in, and you'll be able to go through all of that, and then the answers are at the end of the worksheet. If you scroll down to the next page, just check those just like you would if the answers were in the back of the book. So here we're going to talk about how to evaluate problems in scientific notation. So here we're looking at our first problem, which says 2 times 10 to the 6th times 2.5 times 10 to the negative 10th. Now, we have two numbers in scientific notation we're multiplying, and one way that I like to think about, since it's all being multiplied, this is the same as saying 2 times 10 to the 6th times 2.5 times 10 to the negative 10. And just like we would in earlier lessons, if I had 2, let's say, to the x times x to the 6th times 2.5 times x to the negative 10th, I would reorder these terms so that the like terms were together. So the 2.5 and the 2, and then the exponential terms. And you can do the same thing with scientific notation. So we'd reorder it like this if they were with variables. In this case, we'll say 2 times 2.5 are going to be our decimals, and then our powers of 10. And since they have the same base, we can combine our powers of 10 using addition, since we're multiplying them. 10 to the 6th plus negative 10 is 10 to the 6th minus 10, because the positive and the negative can combine to a subtraction problem. So our powers of 10 simplify to 10 to the negative 4. Now, it's fine to leave this in as negatives in scientific notation. Now, for the decimal, we've got 2 times 2.5, which is equal to 5.0. As we can see here, we only have 1 point in front of the decimal, so it's fine to just leave it as that for our final answer. Let's look at a division problem. We're going to treat this the same way, where we're going to think about our decimal parts and then our powers of 10 separately. So here we have 4 divided by 2, and our powers of 10 are 10 to the 5th over 10 to the 7th. Now 4 over 2 is 2 times 10 to the 5 minus 7, since we're simplifying a division problem. That leaves us with 2 times 10 to the negative 2, which again is a very acceptable answer for scientific notation. There's one other type of problem that we might see like this, and that's where we have an exponential term to an exponent. Now, if you remember from previous years, the way you can follow this rule is that these would then multiply together. So x to the a to the b becomes x to the a times b. Now, again, if you're not sure, you can always just expand. So what I mean by that is take 4 times 10 to the 12th, and if that's squared, that just means times itself again. And so by expanding, you've turned it into a multiplication problem, which is just 4 times 4 and 10 to the 12th times 10 to the 12th, which would be 16 times 10 to the 12 plus 12, which is 24. Now, one thing, and you'll notice that that's the same thing as that if you squared these terms here to say 4 squared times 10 to the 12 times 2, following this rule. So either way, you get the same answer. Now, what I hope that you would notice here is that if the decimal point were correctly in scientific notation, it should be right here after the 1, but it's currently here behind the 6, so we need to move it up one space, and that means that we compensate by adding 1. This is very similar to one thing that we saw in the notes previously, so make sure that you're doing these lessons in order. So we need to move that decimal point up a space, meaning that our final answer would be 1.6 times 10 to the 24 plus 1, which is 25. Now, these small changes happen more often when we're doing problems like this. So, for example, if I'm looking at a division problem, like here, we're going to start off the same way we did before by saying, we're going to say 3 over 6 and 10 to the 5th times 10 to the 7th, over 10 to the 7th, excuse me, so that when we simplify, we turn this into 10 to the negative 2, as we saw in number 2, but we need to then take this term and we need to turn it into our decimal. So what I might do is I could simplify that fraction. 3 over 6 is the same as 1/2. As a decimal, 1/2 is 0.5 times 10 to the negative 2 still. And now the decimal point is 1 too small, which we compensate for by taking away another 1 in the exponent, leaving us with 5.0. If you want to write it like that, that's fine, or just 5, times 10, negative 2 minus 1, which is negative 3, as our final answer. If you want to see one more example of this, you can in the guided notes. Otherwise, feel free to get started. Please leave me any questions that you have on this or any topics from chapters 1 and 2, or any questions that you have about the test in the comments, or you can set up a meeting with me through Zoom at the calendar at the top of the classwork page. I'll talk to you later.